Hello everyone, this is me, Ahmed Al-Garhi. I'm a professor at Marietta College, and today I will give you a short introduction about what is hydraulic fracturing. To give you a good introduction about fracking, we need to cover these items. First, I want you to know what is formation damage, what is well stimulation, what is hydraulic fracking, why we do hydraulic fracking, and the basics of fracking operations, and then finally, fracking mechanics. Okay, let's begin. Imagine the situation. We have sick wells and we have healthy wells, very similar to human. If you feel something wrong with your body and you decide to go and see a doctor, the doctor, what will happen? The doctor will give you a medicine without asking you any question? For sure, no. What will happen is the doctor will try to collect all information about what you're feeling, what is wrong with your body, he will check your body, and then he decide what kind of disease you may have. And finally, he will write you the treatment, he will write you the medicine. Wells are very similar. If your job is a petroleum engineer or reservoir engineer, now your job similar to a doctor. And your well is your patient. And the disease that your well have is the formation damage. So the formation damage is very similar to a disease that make you sick. Formation damage may occur in all formations, may occur anytime, and easily we can identify there is a formation damage whenever we start seeing a loss of well performance, unexpected loss of performance. And this formation damage may change workability. For sure, it will plug your pore throat. It may occur anytime. As I mentioned before, it can take various periods of time. Also, similar to a disease of human, it may be a single disease, maybe a combination of different diseases. So we need to figure out exactly what is the types of formation damage we have. And my advice to you, if you don't know the type of formation damage, please don't do anything. Take your time to study the case. And the last thing to do, whenever you feel that you understand the situation, you write your treatment. You decide if you will do acidizing job or fracking job or any chemical treatment you want. Also, it is better to avoid formation damage, way better than letting your well get sick and then you start thinking of what should be the right treatment. And remember, the treatment of acidizing or fracking is hundreds of thousands of dollars, sometimes millions of dollars. Okay, how to identify a formation damage? Simply, when I see that there is a loss in production, there is a loss in performance, also I can get a sample to the surface and I can do analysis for that sample and I can see there is a formation damage. And also I can send downhole camera, video camera, and check if there is. This is not common, but it's still something doable. And finally, we can do a PLT or production logging to confirm that we have a formation damage. Formation damage is something hard to quantify. So we invented the term skin to quantify formation damage. So whenever you see a positive damage, a positive skin, this means we have a formation damage. If it is high positive value, this means there is severe damage. If we see a negative value for skin, this means we have the well we have is stimulated. Stimulated means we did a frac job, we did acid fracking, we did acidizing, or any kind of treatment may enhance the production. Okay, so one of the models used it to quantify skin, which is Hawkins formula. Hawkins formula, as you see, S is a skin, which is K over Ks. K is the permeability, the reservoir permeability, the original permeability, over Ks, which is the damaged permeability, or the permeability inside the damaged zone. As you see, starting from this line to the well bore, this is a damaged zone. From this line to this line. And the ideal production should be this curve. But as you notice, because of the damage, we have a pressure drop. That delta P happened because we have a positive skin in this formation. There is different types of formation damage. the causes of formation damage may be mechanical, may be chemical. So mechanical causes or mechanical reasons may be like solids invasion. Do you know when this happened? During the first day you drill your reservoir. Because of the drilling fluids, the solids suspended in that fluid get invaded to the formation and start doing a formation damage, start damaging your reservoir permeability. Also, maybe it is workover damage because of the workover fluid. And maybe it is emulsion, water and oil or oil and water, or maybe there's water blockage, and this is very common in gas wells. Also, we may have some chemical types of formation damage, like a precipitation due to incompatible fluids, and we get a precipitate of sulfate or sulfide. Also, we may have fines migration. In the next slide, I will tell you exactly what is fines migration. One of the good questions I like to ask my students, what is the difference between sand production and fines migration? In the next slide, I will try to give you a good answer for this question. And finally, we may have a formation damage because of the bacteria, very similar to, let's say, the SRB or sulfur-reducing bacteria. And it is a very common cause for formation damage. What is fines migration? Again, fines migration, when you have solids inside your reservoir, most likely clays, most likely kaolinite, and these solids moves from a location inside your reservoir to another location inside your reservoir. But these solids not produced, not reached the wellbore and not produced. Again, so if that solids moves from a location inside your reservoir to a second location and may get, trapped and, or plugged, pore throat and damages the permeability, but still this solids inside your reservoir. We call that fines migration. What is very common clays that do that behavior, which is kaolinite. And if these solids get produced to the wellbore, now we call it sand production. Okay? I wish this now clear for you, the difference between fines migration and sand production. Okay, now let's talk about what is well stimulation. By definition, stimulation is anything we do to stimulate the production or make the production better. So we may talking about hydraulic fracking, we may talking about acid fracturing, we may talk about acidizing. So all of these techniques we call it well stimulation. Why? Because it is stimulate my well production, makes my well production way better than normal. So a well stimulation job is a well intervention job that increase the productivity of my oil or gas wells. Okay? And again, it is maybe hydraulic fracking, maybe acid fracking, maybe acidizing job. What is fracking? Simply, fracking is engineered fluid or fluid with specifications. We inject in a high pressure and high rate to my reservoir to break down my reservoir, to crack my reservoir. When we crack the reservoir, we initiate, let's say, two wings. Let's say this is the ideal case in a conventional reservoirs. We initiate two vertical wings of a fracture, and these fractures will keep growing away from the wellbore, and this increase the contact area with my reservoir and increase my productivity. But one of the problems I may have, when you stop pumping, that fracture you created will close. Okay? This is why we need to use something to keep this fracture open. And actually, we use something like this. This powder, we call it sands or proppant, and we inject this with the frac fluid and get trapped inside the frac I'm creating. And whenever you stop pumping and fracture try to close because it's losing pressure, so the fracture is closing, it will close on that proppant, and that proppant has very high permeability, so I will be similar to having a high way for hydrocarbon to reach my wellbore. So I'm still getting a benefit of increasing the contact area with my reservoir. And now, because of the propant, I can keep my fracture open, and I can keep the good communication between my wellbore and my reservoir. Look to this figure. As you see here, this is a vertical well, and this is my reservoir, and I do perforations, and I keep injecting in a high pressure and a high rate until I exceed the resistance of that formation. I break it down. Okay? When you break it down, you increase the contact area with the reservoir, and you start increasing more than expected. And to keep the fracture open, we inject propant with the frac fluid. Look to this horizontal well. This is the horizontal section. We call it lateral. I cannot frac all that lateral in one time, in one stage, so I do it in stages. So I perforate here in this the first stage. Then I pump, I create a fracture. Then I set a plug. Then I perforate again in the next stage. Then I pump and I create a second fracture, and I set a plug, and so on. At the end, I drill these plugs and open my well to production. So why a vertical well produce less than a horizontal well? Simply because the horizontal well has more contact area with my reservoir. Why a frac well produce better than unfracked well? Simply because the fracked well has more contact area with my reservoir. Another reason, because the fracture itself has something similar to a highway, very conductive surface I'm creating, which is the fracture itself, and this gives a very good path for the hydrocarbon to take immediately, in no time, from the reservoir. Whenever it reaches the body of the fracture, it gets immediately to the wellbore and get produced. Okay? To give you some idea about how a frac job looks like, I want to show you that video. You have the link here. This is from Chesapeake, which is a famous company in the United States and one of the major gas producers. And you can get this video from YouTube. Let's watch the video together.
In order to maximize the production potential of the well, the shale formation will be hydraulically fractured. In preparation for the fracturing process, the casing will be perforated in the horizontal portion of the well using tubing-conveyed perforating guns containing explosive charges. The perforated intervals are spaced approximately 50 to 80 feet apart and create a connection between the production casing and the shale formation. With the initial perforating complete, the tubing and perforating guns are pulled to the surface, and the workover rig is replaced by a hydraulic fracturing crew consisting of a number of high-pressure pumps and blending equipment. This equipment will pump a mixture of water and proppant, usually sand, through the newly created perforations in the production casing and into the shale formation. First, water is passed from a water storage impoundment into the blue working tanks depicted on this location. The water is then pulled into a hydration unit, which provides the ability to gel the fluid before it is transferred to the blender. At the blender, proppant and a small amount of chemicals that aid in the fracturing process are added. The blender transfers the fluid and proppant mixture to the pump trucks through the low-pressure side of the manifold. The fracturing pumps increase the pressure of the fluid, sending it back through the high-pressure side of the manifold to the frac tree where it enters the well. The entire fracturing process is controlled from the treatment monitoring van. When the fracturing fluid reaches the perforations, pressure builds until the shale formation fractures, allowing fluid to enter into the formation. Additional fractures are created along natural zones of weakness in the shale. These fractures are contained within the shale formation, well below the ground. After an initial stage of fluid called the pad is pumped to create a fracture area, proppant is added to the fluid and is distributed throughout the newly created fracture network. At the conclusion of the fracturing treatment, the proppant allows the fractures to remain open so that the natural gas can flow into the production casing and to the surface. This completes the first of several stages in the fracturing process. This process is repeated by lowering and pumping down an isolation plug and perforating guns into the wellbore to complete the next stage of fracturing. This time, The tools are conveyed into the well by a wireline unit, which allows the fracturing process to proceed much faster and more efficiently. A lubricator is used to control the pressure of the well while the operation is taking place. On the bottom of the perforating gun, a composite bridge plug is placed to isolate the newly fractured zone. This ensures that the subsequent fracturing treatment is contained in the current zone. The perforating gun is again fired at roughly 50 to 80-foot intervals, creating a connection between the production casing and the shale formation. The fracturing process is then repeated until all of the stages are completed. A typical shale well has approximately 8 to 12 stages of fracturing. At the conclusion of the fracturing operations, the isolation plugs are removed from the well and production can start. The produced fluids are diverted through a flowback manifold into storage tanks. The fluids are then recycled or disposed of according to state and federal regulations.
Please try to watch this video again one more time in your own time, because really there's a lot of information inside this video. Okay, if your decision to work as a frac engineer and this is your dream job, so you need to memorize this figure, this graph, the same way you memorize your name. Look, this is a pumping showing the hydraulic frac job, the x-axis showing the time, the y-axis showing the bottom hole pressure, and the injection rate, theoretically speaking, we are trying to keep it in a constant rate. Here, when you start pumping, you start, the pressure starts rising as a straight line, then get bent to a point, then boom, it goes down. Now you break down your formation. Now your formation is broken. So we call that breakdown pressure, okay? And the pressure will decline in a similar shape to this curve. When you stop pumping, see here we stop pumping, so we stop pumping here, so we call that caution pressure. Somewhere very close to the caution pressure here, we call it ISIP, instantaneous shut-in pressure. And in future lectures, I will explain to you how to get these values and what is the benefits of having these values. And now the pressure keep declining to a point. Now our fracture already closed. So at that zone, when we stop pumping to that point we call it the closure pressure point. Okay, so here we have fracture closure pressure. So at that zone, this is fracture dominated or fracture dominant. Okay, the flow here is the flow we have here. We call it fracture dominated. Okay, starting from this point, now I'm sure that the fracture already closed on the proppant. So starting from this point to the end of the curve, all flow types, all flow regimes I have, we call them reservoir dominated. And again, in the future lectures, I will explain to you by details what is the value, what is the benefit of having these values of closure pressure or ISIP, and what is the benefits of analyzing this pressure curve. As a summary, the applications, there is a wide range of applications of hydraulic fracturing. First, the most important one is to enhance production rate. Okay. Second, as a sand control technique. Remember, when we have a low permeability formation, we use fracking to increase productivity. But one of the major problems we have when we have high permeable formation, like in Gulf of Mexico, let's say when you have a sand formation and it is high permeable, we start producing small particles of sand, solids. We produce solids with the oil and gas we are producing, and this sand production is very harmful to my surface facilities, to my tubing and my surface facilities. So we like to create short and fat fractures to work as a screens inside the formation to stop that sand production. We call that technique frac and pack. Okay? One of the applications of hydraulic fracturing, we may use it in disposal, injecting produce water by hydraulic fracking, injecting drill cuttings by hydraulic fracking, and for sure I will give you a detailed lecture about this application. And finally, sometimes, not sometimes, maybe all the times when we have injectors in a water flooding project, this injector after some time, maybe a month or two, maybe a year or two, these injectors get fractured unintentionally. Why it get fractured? Because I'm injecting water from the surface and that water is colder than the formation temperature, so I'm keep cooling down my formation, I'm keep lowering my breakdown pressure. To a point, my formation get break down unintentionally and a hydraulic fracture initiated. Okay? So what is missing in this presentation to cover the last three items? Why we do hydraulic fracking, the basics of fracking operations, and finally the fracking mechanics. If you're still interested to learn about these three items, please wait for my second lecture. Thank you very much for your time. If you like this video, please share it with friends. Have a wonderful day. Thank you.